You ever stop to think about what actually happens behind your screen? I mean, it feels like magic, right? You click something and boom, it's there. But it's not magic. It's an incredible globe-spanning chain reaction. And today, we're going to follow that journey step by step.
Okay, so picture this. You click a link. It feels instant, but in those few milliseconds, what is really going on? That one simple click kicks off this insane, high-speed journey across the entire planet. Let's follow the data and see where it goes.
All right, so that click, that's the starting gun. The race has begun. And the very first thing that happens is your computer has to send out a message. It needs to ask another computer, which could be literally anywhere in the world, for the information you just asked for.
So, this all kicks off a little digital conversation. And it's based on something called the client-server model. Think of your browser as the client. You're the customer in the restaurant. You're making the request. And that remote computer that has the web page, that's the server. Its only job is to listen for your order and serve it up.
But, before your request can hit the road, it's got to get packed up for the journey. You can't just send a letter, right? You need an envelope, an address, a stamp, the whole deal. Well, in the digital world, it's kind of the same idea, just way, way more complex. So for any of this to work, all these different computers have to speak the exact same language. And that shared language is called a protocol. Just think of it like a universal rulebook for talking to each other. It makes sure that your request is perfectly understood whether it's going next door or to the other side of the planet.
Okay, this process is called encapsulation. And honestly, it's just like a digital post office with different departments. First up, the application layer. It writes the letter. That's your actual HTTP request. Then the transport layer comes in and chops that letter up into smaller postcard-sized pieces, which are way easier to send. After that, the network layer slaps the final destination address on each one of those postcards. And last, the data link layer adds a little local address, basically just telling it how to get to the very next stop, like your Wi-Fi router.
Now, back at that transport layer, your computer has to pick a delivery service. For something like a web page, it's almost always going to use TCP. Think of TCP as certified mail. Every single piece is tracked, it's accounted for, and delivery is guaranteed. But for something like a video call, it might use UDP. UDP is more like a postcard. It's super fast because there's no tracking, and hey, if one tiny piece gets lost along the way, who cares? It's better to just keep the stream flowing smoothly.
So after all that chopping and wrapping and addressing, we finally have it, our finished product, the packet. This little guy is the travel-ready unit of data. It's all bundled up, perfectly addressed, and it is ready to be launched out onto the internet.
All right, our packets are packed and ready to go. Now comes the hard part. They've got to navigate the massive, sprawling, super complex highway of connections we call the internet, all to find one specific server that, again, could be thousands of miles away.
And the real heroes of this whole journey, they're the routers. Seriously, just think of them as the traffic cops of the internet. A packet arrives, and in a fraction of a millisecond, the router looks at the destination address and makes one simple decision. What is the fastest way to send this along to the next stop? It doesn't know the whole route, it just knows the best path from right here, right now.
And this is where things get really, really cool. The internet is what's called a datagram network. What that means is there's no single dedicated highway from you to the server. Nope. Each packet is its own independent traveler. So all the little packets from your one click might actually take completely different paths to get to the same place, dodging digital traffic jams along the way. It's a brilliant system that makes sure the message gets through no matter what.
Now, if you zoom way out, all of these connections, they form bigger patterns. We call them topologies. You've got mesh, star, bus. They look like spider webs or stars. You don't really need to get bogged down in the details. Just know that all these different local blueprints are what connect together to form the one giant global internet that our packets are zipping across.
Okay, so our packet is hopping from router to router at incredible speed. But how? How is it physically traveling? I mean, it's not magic. Before it even leaves your house, it has to go through one last absolutely crucial transformation. It has to go from being pure digital information into a real physical signal.
And that is the job of what's called the physical layer. It takes all those digital ones and zeros that make up our packet and translates them into actual, real-world energy. We're talking electrical pulses shooting down a copper cable, little flashes of light zipping through fiber optic lines, or radio waves for your Wi-Fi. The data is now physically on the move, pretty much at the speed of light.
So after hopping across who knows how many routers in literally the blink of an eye, our packets have made it. They've arrived at the destination server. But wait, the job is not done, not even close. Now the server has to unpack the whole message, and then get ready to do this entire trip all over again, but in reverse.
This part is called de-encapsulation, which is just a fancy word for the unpacking process. The server basically does everything we just talked about, but backwards. It unwraps each layer of addressing, kind of like opening a birthday present. It puts all those little postcard-sized packets back together in the correct order until, finally, it can read your original, complete request.
Aha! The server finally understands what you wanted, so it gets to work. It gathers up all the data for the web page, all the text, the images, everything, and it packages all of that stuff up into brand new packets. And then, it sends them all flying back to you, following the exact same wild journey, just in reverse.
So what makes this whole incredible thing possible? Well, it's collaboration on a scale that is just mind-boggling. See, the internet isn't one single thing. It's a network of hundreds of thousands of separate individual networks, and every single one of them agrees to play nice, to speak the same languages, the same protocols, and to forward packets for everybody else. It is quite literally the largest cooperative project in the history of humanity.
So there you have it. From one simple click on your screen to a server halfway around the world and all the way back again. And it all happens in less time than it takes you to blink. Your request gets packed, sent, routed, received, unpacked, and answered. That, right there, is the incredible, invisible architecture of the internet.
So the next time you click a link, maybe you'll remember that invisible dance of protocols and packets happening behind the scenes. It's a system that wasn't built by one company or one government, but by global collaboration, a shared agreement on the rules. And it really makes you wonder, doesn't it? If a network built on openness and cooperation completely changed our world, what will the next one be built on?